All right, today we're going to do slides 13, 14, 15, and 16. So we're going to look at the sun and we're going to look at the moon. All right, we are going to start off on slide 13 and we've got a video.
While billions of stars are scattered throughout the universe, the one at the center of our solar system plays a special role for us here on Earth. Our sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our sun. The sun's fiery nature, along with a tremendous gravitational pull and an extensive magnetic field, helped it to become the heart of our solar system. The sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. In terms of atom count, the sun is about 91% hydrogen, the sun's fuel, 8.9% helium, and 0.1% heavier elements, such as carbon and nitrogen. Due to the sun's extreme temperatures, these elements stay in a gas-like phase called plasma. In the core, temperatures reaching at least 27 million degrees Fahrenheit, combined with the sun's powerful gravity, fuse together hydrogen molecules to create helium. Called thermonuclear fusion, this releases an enormous amount of energy in the form of radiation, electricity, solar wind, and, as we experience on Earth, life-giving heat and light. Such volatility is contained thanks to the sun's tremendous gravity. It's strong enough to hold the solar system intact and is primarily due to the sun's size and mass. Our sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all 8 planets inside nearly 600 times. It also contains approximately 99.8% of all the mass in the solar system. Because of this mass, the sun has a great pull on the fabric of space, creating a gravitational force that causes nearby planetary bodies to be drawn toward it. This gravitational pull allows the sun to hold together a system of 8 planets, potentially dozens of dwarf planets, at least 170 moons, and countless comets and asteroids. Without the sun's gravity, these celestial bodies would drift off into deep space. Another critical property of the sun is its magnetic field, which encapsulates the entire solar system. Called the heliosphere, this force field protects the planets from harmful cosmic radiation. It's caused by the sun's plasma pushing electrically charged particles toward the star's poles. This process turns the sun into a giant magnet. Although the sun's magnetic field is invisible to the naked eye, its effects are noticeable. On the sun's surface are dark areas called sunspots, which mark strong pockets of magnetism. On Earth and on some of the other planets, the sun's magnetic field interacts with their atmospheres, resulting in beautiful auroras. Despite its size and strength, the sun will not last forever. In about 6.5 billion years, it will run out of its hydrogen fuel, expand to envelop Mercury, Venus, and even Earth, and then collapse into a small star known as a white dwarf. In the meantime, the sun will continue to play a critical role in the system that bears its name. The sun's protective magnetic field, tremendous gravitational pull, and ability to create vast amounts of energy will protect, contain, and give life to our solar system.
Okay, so the sun produces light and heat that we depend on. It is a medium-sized star at the center of our solar system. Remember, I say this all the time. Remember, it is not the biggest star. It's not even a very special star. It's just special to us, and it looks big to us because it is the closest star to us. So it is much closer than all the other stars that you see in the night sky. Those stars are much, much farther away than the sun. And so the sun is a star. It is a medium-sized star. It looks large to us because it is so close. Well, not because it's close, because it's closer related to the other stars. All right, our sun is the most massive object in our solar system, and so it has the largest gravitational pull, and planets orbit the sun because of the sun's gravity. So the sun's gravity pull keeps all of the planets in their orbits. Without the sun, as you saw in the video, all the planets would shoot off into space. They would no longer stay in their little circular orbit. The sun is made up mostly of hydrogen, which is a gas. It also contains helium and a tiny bit of carbon, nitrogen, and other heavier elements. So the sun also has layers. All right, so the corona is the outer section. Then we have the chromosphere, then the photosphere. Then we have what we call the convective zone or conductive zone, then the radiative zone, and then finally the core. All right, comparing our sun to the Earth. So we're just going to drag and drop these where they belong in the Venn diagram. Remember with the Venn diagram, in the middle is where you put things that describe both topics. So a star would be just the sun. The Earth is not a star. The Earth is a planet. The Earth has liquid water, whereas the sun does not. They both actually have an atmosphere. All right, they both have gravity. Made up of helium and hydrogen would be the sun. Produces light would be the sun. The Earth does not produce light of its own, but the Earth is composed of rock. So make sure you have those in the correct spot and pause this video if you need to. All right, so similarities between the sun and the Earth. We're just going to type into this box. Both have an atmosphere. I'm sorry, let's put this into a complete sentence. And there's a sentence stem there for you if you need it. The similarities between the sun and Earth include both have an atmosphere and both have gravity. So those are really the only two similarities we can really come up with between the Earth and the sun. All right, now we're going to look a little bit at the moon, and then we're going to do the same thing with the moon. We're going to compare the Earth and the moon. All right, so first we've got a video.
Over 150 moons orbit the solar system's planets, and one of those moons calls Earth home. The moon was formed about 4.5 billion years ago, when, according to one theory, the Earth slammed into another early planet. Debris from this collision began to orbit Earth and accumulated, forming today's moon. The moon is the fifth largest natural satellite in the solar system, with a diameter just under the width of China. It's composed of an iron-rich core, plus a mantle and crust containing minerals made of magnesium, oxygen, and silicon. The moon's surface was once geologically active and covered in an ocean of magma. But today, apart from traces of water ice, the surface is completely covered in dust and rocky debris. Countless craters dot the moon's surface, each formed by objects such as meteoroids, comets, and asteroids crashing onto the moon. The largest crater, the South Pole Aitken Basin, spans across a quarter of the moon's surface and is nearly deep enough to fit Mount Everest inside. The moon orbits our planet at an average distance of 30 Earths. It rotates at the same rate that it revolves. So as it revolves around our planet, the same side of the moon faces the Earth at all times. From the Earth's surface, we can observe 8 distinct, traditionally recognized stages of the moon's illumination. Called lunar phases, they have been observed for thousands of years and even provided the basis for the earliest calendars. For most of human history, the moon could only be studied from afar. But on July 20th, 1969, humans were able to close that distance with the American spaceflight mission Apollo 11.
That's one small step for man, one giant leap for mankind.
It placed humans on the moon for the very first time, bringing our understanding of Earth's only natural satellite one step closer.
Okay, so the moon is a natural satellite that orbits around the Earth. It is made up of rock, similar to the Earth. It has lots of craters. It does have mountains, inactive volcanoes, and large plains. It is a sphere that is 1/4 the size of the Earth. It does have ice at its dark, cold poles, and NASA recently confirmed that there are water molecules on the sunlit surface of the moon. The moon has a small amount of gravity, so it does have gravity, but a very small amount relative to its size. The moon's structure is similar to Earth. We have the crust on the outside, then the mantle, then we have the inner core, yeah, there we go. The very inner core is liquid and solid. Okay, so comparing the moon to the Earth. All right, so remember in the middle goes the similarities. Okay, water on most of its surface would be Earth. Keyword, there would be water on most of its surface. Rocky composition would be both. They are both made of rock. The moon is a natural satellite of Earth. It has a little bit of gravity. I would say that would be both, because I'm thinking relative to the sun, they both have little gravity. The moon has less gravity than the Earth because it's much smaller. So I'm wondering if maybe she meant for us to put it over here, but I would prefer it in the middle because they do both have little gravity comparative to the sun. They are both spherical. They do both have frozen water. Remember that it said the moon does have traces of frozen water on it. Only the Earth is a planet, and only the Earth supports life. All right, so similarities would be they are spheres, they are rocky, they have gravity, they have frozen water, and I'm going to go ahead and add craters. Now, one important difference that we don't have here that I want to mention is that the Earth does have an atmosphere and the moon does not. The moon does not have an atmosphere, and that's part of why you can see so many craters. That's part of why the craters and that footprint stay there, because there is no atmosphere, there's no moving air to blow around that dust and to erase any of those craters or footprints. And so the moon has no atmosphere, which is also part of why it gets struck so much by asteroids. So that's also why it has so many craters, because it doesn't have an atmosphere to slow down those asteroids that are hitting it. Whereas Earth has a protective atmosphere, and a lot of times whenever asteroids will come close, they'll burn up in the atmosphere before they reach the Earth. So something to remember, the Earth and the sun both have an atmosphere. The moon does not have an atmosphere. All right, and those are it for your notes for today.